So I wanted to back up for a second and talk about where we are. We've put a lot of work into this study, and a lot of times, the distance that we've covered so far, this is about as far as we get through during the data collection SCP process. So all the way through the facilities, through uh, doing our baseline, base case, better, and best. We have results for all of those. Usually at this point, we'd be ready to go to the SCP, and then normally there are some tweaks that we continue to do during that final process to either meet certain energy reduction goals, but it's primarily been focused on the buildings, on the facilities themselves. So here we've added those alternatives. We've gone all the way through with the buildings, and now we're going to look from the supply side or from the installation scale, looking at the entire area and what we can do to those buildings together collectively that may be more cost effective than what we would do to them individually. So that's where we are. Facility loads was where we addressed all those things in the buildings. We've moved again onto this installation or subsection. And the great thing is a lot of the information has been passed forward here when we created those new alternatives. So we start off with just a detail screen here. We're going to go back now to the cluster and networks. And we've seen these screens before as we set up the baseline and base case. And you can see those here as the subtabs within this larger cluster and networks section. And so within this section, again, as a review, we've grouped together the buildings basically by the systems that are serving their heating and cooling demands. So generally, electric demand, we're only metering up at the whole installation, and so we're not as concerned about drawing lines between them for this. But here, the centralized buildings, these buildings are all connected to a central plant and have thermal networks connecting them. Here, just a heating network. And then the cluster, just group of buildings, we're just using the terminology cluster for this group of buildings. These all have decentralized boilers and chillers serving their individual systems. So they're connected to the natural gas line, to the electric grid, and just have individual equipment serving their loads. So we've divided it up this way. This is the baseline. We can scan across and look at the base case. It takes just a moment to load. So we have a different number of buildings here. And we may remember this is mostly review from when we set up the base case in the past. We have 28 buildings here and 37. That's a little different than what we had in the baseline. Now when we went forward, we have the same buildings because all three of these, base case, better case, and best case, these are all our future scenarios, kind of the end point for these future scenarios. And we have this phasing report at the end. We talked about this a little bit 2 weeks ago, where we can take these future scenarios and then kind of draw out in a timeline when different improvements would be made or when changes to the buildings would be made. But these are kind of the end cases for these different scenarios when all the things have been done to the buildings. So we have the same number of buildings going between these last three alternatives, these last three alternatives. So we're not going to see a change when we go to the next one for our clusters. So the same buildings that are in the same clusters, still 28 and 37, and it would be the same case for the best case. And I didn't have to reset this up because we're building on the base case. So again, benefits. It took quite a while to get to this point, but a lot of the work here we can get high amounts of value with a relatively small additional amount of work. So there's nothing that really needs to be done up through this point. We're going to continue over to the equipment and measures. In this whole process, if we've gotten through the buildings and we've led up to this point, it won't take very much longer to get through and have alternatives for or finish this through the installation and subsection parts of the tool. All right, so we already came through and added equipment, the decentralized equipment. You remember it's just these top two pieces, just boilers and chillers. And the only thing we really had to change here was the cost. So the operations and maintenance costs. And for the baseline, we're saying this is existing equipment, so there's no installation cost associated with it. But we do estimate the operations and maintenance costs for that equipment. Actually, I'm seeing that this O&M cost was left here. I tried to update these numbers ahead of time, before the course just because it's a lot of data entry, and I'm going to show you where those numbers come from. So let me scan across. I've got an Excel sheet we're going to pull up here. And it should be this one. Oh, actually one other. So I tried to show where this came from. All right, so I talked before about these automated Excel spreadsheets that we'll be able to just download and look at the data and put that into the study. So here you can see it's been broken up. My intention was to have all of this in ahead of time. It looks like we're actually missing one. And I can tell that. Let's go back to it for a second. So we're in the decentralized cluster in the baseline, and it's showing this is just a default O&M cost. And so we need to change that from the default value to our predicted value for this group. So I'm going to go to the Excel sheet to take a look and pull that data. Now before I go there, let's talk about where this Excel sheet comes from. This is, in the past, we've had to do this manually or create these Excel sheets to determine what the approximate installation cost and O&M costs would be for this equipment, and we've talked about doing that, and we've also talked about how that's going to be incorporated into the tool. And all of that work has been done. It's still being tested. So that's in our development tool. So I'm going to click over here. You can see this is the development tool here. And there's an Excel download here back in the facility load section in the results and then demand by end use. So I'm in this table right now of data, and demand by end use is basically going to show us the peak values. So this is a different study, just a test study, just to show you the concept because it hasn't yet been pushed forward to the production version. But for any studies that are coming up particularly soon, it should be pushed out by that time. I still want to be able to show the capability of it here. So you can click download on this Excel, and it should show up just like this. So we'll have kind of a breakdown here with each of the alternatives listed, and then the total cost, total investment cost for chillers for each one of these. And then similarly for the boilers and domestic hot water heaters, we kind of group them together. There's a total listed here and then the breakdown down below. And then here below this, we've got the operations and maintenance costs. So I would just go through and manually take this data that's already been calculated and enter it into the tool. So this is just the one that I downloaded directly from that development one. I had to do a little bit more work for ours since it's not in the production version yet. All right, so I'm going to close out of this, and we'll actually close out of the dev one in general. That was just to show where this is located and where you'll be able to get to it very shortly. So going back here, I know that I need to find for the baseline, the decentralized cluster, I need to find the O&M costs for the boilers. So over here, looking at the O&M costs for decentralized and the boilers, we've got, looks like that one was supposed to be about 82,000, and for chillers it's supposed to be 213. So back quickly, okay, 82. And we've discussed these previously, but all of these numbers are based off of the costing data tables. This information comes out of RS means. These tables are you can easily find them in this download. Anything could be adjusted in the future. All right, so click off of that and make sure that this one has been updated as well. Okay, so we've got an updated value here. Anytime that you make a change to the equipment and measures table, you're going to see that it changes to this light pink or magenta color. We'll go ahead and save those changes. So this is basically all you'd need to do on your first pass through. Normally the baseline and base case, this would already be done. This would be work that we've already completed. And just as a review, you'll see that the default value was still there for we're in the centralized cluster right now, and you'll see that the default value is still there for boilers, but that's because we're not actually using the boilers. This is where we've got the central plant supplying it. So you'll see that there are no distributed boilers for this solution. Okay, go across to the base case and just double check that everything was saved correctly. I ran through this study, I copied the study and ran through it on another study, just copying it over, and then went back through and entered this data so it wouldn't slow us down, but I just want to make sure that everything saved correctly. We could obviously do it just as easily together, but it's a little bit cumbersome, takes a little extra time, and I don't know that there's a lot of teaching value in that. So I'm scanning across to see that those default values have been changed, and that they saved correctly. Again, expecting only changes down here for the centralized, and then jumping down to decentralized. Okay, everything looks good. And checking the base case. So you can see this would be a pretty quick process. You download that Excel tab, the Excel document, and then go through, enter those values, which is pretty straightforward. We'd be able to continue then on after this. All right, so everything's been entered. We're going to continue forward to the constraints. On this page, since there's a specific call out for the Save Changes button, if after we've saved it, we could just click to go ahead, but we know that a good process throughout this tool in general is to click Continue to move us forward to make sure everything gets saved in the process. All right, and again, at this point, there's not much that we would need to do in the constraints section. These are all a little bit more advanced constraints if we wanted to look at something like a minimum electric supply that we needed for each cluster within an alternative. We could set those things here, or any renewable constraints, different economic constraints. And we've talked about these a little bit in the past, so I'm going to go through them really quickly and move on to the next section. We could always come back and make changes, especially when we start kind of branching off from these standard alternatives, which we'll be doing here in just a minute. I think that's where we can really see a lot of very quick changes to the process and add a lot of value. All right, so we're going to go ahead and optimize these. So with the equipment that we have, this is really just, it's very much like a simulation. It's just running these alternatives with the supply equipment that's available, which for most of the situation most of these cases, it's the decentralized equipment, the boilers and chillers. And there's not a lot that's happening in terms of optimizing that. It's just running it based on the loads for those buildings that have been calculated back at the facility load section. Those Energy Plus loads have been passed forward, and now they're being fulfilled. All of those heating and cooling loads are being fulfilled by the boilers and chillers for those buildings. Similarly, the buildings that are connected to the central plant, those central plant boilers are running and consuming a certain amount of natural gas, and all of that's being calculated here, and we'll get to see the results here in a minute after the optimization is complete. Where this is really powerful is the next step. So as soon as we go through here and they've all successfully run, we're going to take a branch off of one of these, very likely off of the best case, and look at adding PV, at looking at reducing the source energy by adding a certain amount of PV. We could take it down to 30% of the original source energy, or some metric like that, and add that into the constraints and add in the information so that we can analyze PV. And then similarly look at adding cogeneration technologies to the central plant. Let's go ahead and hit update. This works very similarly. You'll get very comfortable using these two kind of screens between the facility loads and then also installation or subsection. We both have a simulation tab over on the facility loads, and then here it's the optimization tab where you'll see the results just running through this modeling in a very similar display. And so we talked that a little bit about, generally I'd say within a minute, certainly within 2 minutes, you'll have your results back. So move forward to the results. And this isn't going to be too interesting now because we're using basically the existing equipment. We're going to be pivoting away from that here in just a minute. But if you want to look at that equipment, again, you can go to the equipment overview. And this will show what equipment was used or was present for each one of these scenarios. So decentralized, this is going to look very familiar. We just have the distributed chillers and boilers. and it's just a generic or arbitrary size here. We've already sized them back in this document. We'd be able to look, let's see, I'll pull down this one again. So this is just a review of that document, but if you needed to find out what size equipment was actually selected for each piece, you could scan across in the document and find, let's see, so matching the chillers, you actually have the chiller and boiler sizes listed here, and then the costs of those that are just basically referencing that lookup table and then summing all of those things up. So it's easy to trace back to make sure that you've got the appropriate size on these if someone questions it. I think generally you won't need to do it at the planning level, but if someone's saying, how did you come up with that number? You can say, we're taking the loads for each one of these building groups, dividing it up by the building, number of buildings in that building group, and then approximately sizing equipment to the peaks that were developed by that Energy Plus software, and then summing up all of those costs in this spreadsheet. Okay. So we can see the equipment here, and then similarly the centralized equipment. We're going to see the still distributed chillers. Remember, this is just a hot water plant. It's not a chilling plant. There's no chilled water distribution. And then we've got central boilers. But so relatively recently, all of our costing now for the decentralized equipment, here there seems to be, there's an issue with it processing without doing something like this. But this is, I think, instructive to what you're saying. Let's go ahead across here. So this was actually this was a test example. Let me show this one. Okay. So you'll see that the costs actually go down looking across here. So these are for the chillers. I realize this is a little harder to read. And I should say there's one more comment to make about this. Most of your situations, most of the studies that we're going to do, we're looking at one cluster. So the whole concept of clustering buildings together and doing analysis that way was developed quite a while ago, and we've been focusing on individual areas using the tool. And so it turns out that most of the time, I'd say at least 90% of the time, our studies only have one cluster. And I intentionally put 2 in here just to show the capability. But right now, our functionality for estimating costs is back at the facility load section. So I had to kind of arbitrarily pull out 2 clusters here, and that's what added a little bit of extra work. I think we're going to be building in that capability onto the clustering section in the future, but for now and for 90+% of the SCPs we work on, you're just going to have a single one here, and it's going to look very simple, which is why I wanted to provide this example. Here, there's only one cluster for each scenario, and so it's straightforward to take this information out and use it in that equipment and measures. If you have 2 clusters, at this point, just give me a call and I'll help out until we have the functionality directly built into the tool. But going back to the point that Richard was making, if you scan across here, and again, I realize it's a little messy with multiple clusters shown here. For chillers, you'll see here we're looking at the base case. And so we've got about 10 million cost for chillers for the base case. But if you go to the better case, it drops down to about 5 million. We've had a massive reduction in the peaks, especially. So in the energy usage, but even more important for sizing the equipment is the peak that it's going to see. And then similarly, we don't see a massive reduction, I think partly just because of the sizing for equipment, and it's not entirely continuous when you're picking equipment. We've got some set sizes we're going with. So even if there's a reduction in load, if it doesn't go down to the next size piece of equipment, you're not going to see a cost reduction. But between these, you can see a drop down in the actual cost for the equipment as we improve the buildings. And I think that's what we've been looking for quite a while, to see that impact. And for boilers, let's see. We do see a little bit of a difference here with domestic hot water. It looks like we're not seeing a lot between better case and best case for the boilers as well, but we do see it again for for the domestic hot water heaters. So just that plan going forward, that the costs are going to decrease for your supply equipment as well. And we're going to notice that both on with central systems, that again we usually only see maybe in about maybe 15 or 20% of the SCPs we're doing. Again, still focused on a single cluster, but we're also going to see that cost reduction for the single building HVAC equipment, the boilers and chillers as well. Okay, and you wouldn't notice that in this table, because we're not showing cost information. That is another update that's coming out before long. We're working on incorporating the cost information directly in here. Not necessarily totals, but some costs associated with each one of these items. Especially for when we've got things like PV and the solutions, we'll be able to have a nice table here that shows this is the scale, this is the capacity, and here's the cost for each item. So you don't have to scan back to the equipment and measures to get that information. So you can currently do it that way, just looking back at the equipment that was chosen here and scan back for all the pricing information and efficiency information back in the equipment and measures table. But again, coming out shortly, we'll have that added information here in the equipment overview.